Hello everyone. Today's topic is operations on real numbers. What are operations on real number? There are four operations in mathematics: addition, subtraction, multiplication and division. Now, if we add, subtract, multiply, divide two rational numbers, we always get a rational number. Like, for example, 1 by 2 is a rational number and 1 by 3 is also a rational number. If we add these two rational numbers, we get 5 by 6, which is again a rational number. So again, if we subtract two rational numbers, 1 by 2 minus 1 by 3, we get 1 by 6, which is again a rational number. Again, if we find the product of two rational numbers, we get a rational number 1 by 6. If we divide two rational numbers except 0, if we divide two rational numbers, we get a rational number which is 3 by 2. On dividing 1 by 2 with 1 by 3, we get 3 by 2, which is again a rational number. Next is, if we add, subtract, multiply, divide a rational number and an irrational number, we always get an irrational number. How? Let us see an example. Example is 2 plus root 2. 2 is rational number and root 2 is irrational. Value of root 2 is 1.4142 and so on. So after adding, we get 3.4142 and so on. This shows the decimal expansion is non-terminating and non-recurring, with that is of irrational. So it means it is a irrational number. So 2 plus root 2, rational plus irrational gives us irrational number. Again, rational, 2 is rational, root 2 is irrational. Rational minus irrational gives you irrational number 0.5857 and so on, because this shows a decimal expansion is non-terminating and non-recurring. Then 2 into root 2, rational into irrational again gives us irrational number, because this again 2.8284 and so on shows the decimal expansion as non-terminating, non-recurring. So again it is an irrational number. And the product and the division of rational and irrational number also gives us an irrational number 1.4142 and so on. So we get an irrational number. So if we add two rational numbers, we always get a rational number. If we add rational and irrational, we always get an irrational number. Now the third case is, if we add, subtract, multiply or divide two irrational numbers. Now if the case is, if we add, subtract, multiply or divide two irrational numbers, what is the result? The result may be rational or irrational number. Now see how. Let us take an example. Root 2 is an irrational number and minus root 2 is again a negative irrational number. So if we add these two irrational numbers, root 2 plus minus is minus, root 2 minus root 2 gives us 0, and 0 is a rational number. But if we take a case of root 2 plus root 2, now you can see root 2 has 1 in front of root 2, 1 is there, and again root 2 has a rational part 1 in front of it. So taking root 2 common, 1 plus 1 gives us 2, so it becomes 2 root 2. Rational into irrational always gives us irrational. So addition of two irrational numbers may give us irrational number. Now the third example is root 2 into root 2. Both are irrational and the product is root 4. Root 4 is equal to 2 because 4 is a perfect square and its square root is 2, which is again a rational number. Division of two irrational numbers may give us a rational number 1, or it may give us an irrational number root 2 by root 3. If we divide two irrational numbers, we may get an irrational number and we may get a rational number. Now there are some identities related to square roots. What are these identities? Root a into b. Root a into b can be written separately as root a into root b, or you can do it in inverse way also. Root a into root b, you can write it in this form also. In one common square root, root in a into b can be multiplied. Second is root a upon b can be written as root a upon root b separately. And then it can be simplified. Root a plus root b into root a minus root b gives us a minus b. Using the same identity which you have previously done in class 8, a plus b into a minus b, that is a square minus b square. So root a square minus root b square give us a minus b. So fourth is a plus root b and a minus root b. So the answer is a square minus b. Fifth identity is root a plus root b into root c plus root d gives us this result. How it comes? Root a into root c. Irrational into irrational can be multiplied like this. Root a into root b is root ab. Similarly, root a into root c gives us root ac. Then root a into root d gives us root ad plus sign, because both have plus sign. So before every term we have to write plus sign. Root a into c gives us root ac plus root ad plus root bc plus root bd. So this is fifth identity. Sixth identity is root a plus root b whole square. Using identity a plus b whole square, a square plus b square, a square plus b square plus 2ab. So a square, root a square is a and root b square is b. So it becomes a plus b plus 2 root ab. So these are some identities which will be helpful to us in solving the sums of exercise 1.5. Now come to exercise 1.5. Question number 1. Classify the following numbers as rational or irrational. So in these 5 parts, we have to tell which part shows rational and which part shows irrational number. So this question number 1 is based on operation of rational and irrational numbers. Question number 1, first part is 2 minus root 5. We know that 2 is rational number and root 5 is irrational number. So rational minus irrational always give us irrational number. So it means 2 minus root 5 is an irrational number. Second part is 3 plus root 23 minus root 23. After opening the bracket, root 23 minus root 23 will cancel out and we are left with 3, which is a rational number. Third part is 2 root 7 upon 7 root 7. Root 7 and root 7 will cancel out and we are left with 2 by 7, which is again a rational number. Fourth part is 1 by root 2. Now you can see 1 is rational and root 2 is irrational. So rational divided by irrational always gives us irrational numbers. So therefore 1 by root 2 is an irrational number. Next, fifth part is 2 pi. We know that pi is an irrational number and 2 is rational. So rational into irrational gives us irrational number. So therefore 2 pi is an irrational number. So this completes question number 1.